Hi everyone, welcome to this lecture. So in this lecture, we are going to study the entropy. So entropy is not a new topic in sciences and engineering. We have studied entropy in physics, in thermodynamics, and in other branches of science. But in this lecture, we are going to learn entropy with respect to the context of decision tree. So in the context of a decision trees, entropy is a measure of disorder or impurity in the node. Thus, a node with more variable compositions, such as 2 yes and 2 no, has high entropy or impurity than a node which has only yes or only no. The maximum value of entropy is 1 and minimum value is 0. So the entropy is a value, it is a physical quantity whose minimum value is 0 and the maximum value is 1. So basically, entropy tell us about the impurity of a node, whether it is the parent node or a children node or the root node or a leaf or a terminal node. So what happens if the entropy of a node is high? It means that node is impure. It means we need further split of that node. Look at this example. Suppose we have a node where we have 4 data samples and 2 belongs to class yes and 2 belongs to class no. So here the samples are equally divided into 2 classes. In that case, the entropy will be 1. On the other hand, if we have 4 sample belongs to only one class, that is either yes or either no, in that case, there is no impurity in a node and the value of entropy will be 0. So here is the explanation of minimum value and the maximum value of the entropy. So the leaf nodes which have all instances belonging a single class would have an entropy 0. That is those nodes, that is those children nodes especially, where the classification has been finalized, so that nodes have entropy is equals to 0. That is where all the sample belongs to a single class. On the other hand, if we have the node where the classes are divided equally, has the maximum value of the entropy. Here is the example. Suppose this is our tree and it has some features like health condition. We have the feature age. Okay, now this tree starts from here. If we see the value of entropy, it is very high. Why? Because we have 13 samples. Out of 13 samples, 6 belongs to class 0 and 7 belongs to class 1. If there would be 14 samples and all these 14 samples are divided equally into each class, that is 7 and 7, in that case, the entropy would be 1. So here we can see that entropy is very high because we have the samples divided into more than one classes. Now here the decision has been done. The entropy is 0. We have 5 samples and all 5 sample values belongs to class 0. There is no sample belongs to class 1. So in that case, the classification has been finalized. So when the classification has been finalized, so the entropy of that node is 0 and there is no impurity associated with that node. Now here we can see still we have 8 sample, but they are divided into 2 classes. They do not belong to a single class. In that case, the entropy is not 0 and this node has impurity and we need to further split this node. Now look at this node. Here the entropy is 0. Here the entropy is 0. Here the entropy is also 0. So for these 3 nodes, the entropy is 0 because the sample belongs to only one class. Here we have 4 samples and all belongs to class 1. Here we have 1 sample and all belongs to the first class, which is a 0 class. Here we have 3 sample and all belongs to class 1. So those nodes where the classification has been finalized has the value of entropy is equals to 0 and they are called pure node. On the other hand, those nodes where the entropy value is high are the impure node and we need to further split those nodes. Now, why we calculate entropy? Basically, we want to calculate the information gain so that we can construct our tree from that information gain. So information gain is the difference between the entropy value of the parent node and the entropy value of the children node. But how we calculate the entropy? So this is the equation of calculation of the entropy. If we have n samples from 1 to n, we will calculate the probability of each sample. Then we will take the log of the probability and then we will multiply them in order to find the entropy. So we will calculate the entropy of all the parent nodes and the children node. Since every parent node has more than one child node, in that case, we will take the weighted average of the nodes and then subtract it from the entropy of the parent node. So in this lecture, we study about the entropy. Entropy is a very important criteria which tell us about the information gain of the node. So based on the entropy, we decide that whether we need to split the node further or not. So I hope you understood this basic concept of the entropy. Thanks for listening, and I will see you in the next lecture.